Hey everybody, welcome back. Welcome to PreCal. If you haven't yet, make sure that you go to Google Classroom, open up a copy of today's slides. I think we're on day 10, so it is day 10 today. Welcome back, everyone. Again, it's been a while. Let's jump into our check-in question. So, April 5th, everyone. Oh, I like this. What was your favorite toy as a child? Go ahead and put that there into the chat. Let's see what y'all had as a favorite toy. All right, we got some Legos. What you call those? So I don't know. I was a very simple kid. I would play with slinkies, or those like squishy stuff. I don't know, like those sparkle squishy goo. I don't know why. I would play with that. But there were many other toys, but for some reason I was really into that stuff. Oh, cabbage dolls. Those were so cute. We have a small dollhouse. I never had a dollhouse and I always wanted one. A penguin plush. Oh, yo-yos. I forgot. There was like a whole thing where my elementary school had a thing with yo-yos. So there was a point in time where I had a yo-yo, but I never knew how to use it. We have Barbie dolls, Pokemon. I don't think I had one. Barbies. My younger sister, her favorite toy was a balloon. She would just play with a balloon, just making sure it doesn't hit the ground and just hitting it. We always had like such simple interest in toys. We have I don't remember, my duck that sang a song. That's so cute. I had like a Barney toy too when I was younger, but I think I got creeped out by it. We got stuffed animals. Those are awesome. Welcome, welcome if you just came in. We're checking in on what our favorite toy was as a child. That was me too. Barbies, but fake Barbies. Me too. Like the ones that were like they break easily. I don't know if that's what you mean, but that's what I would get too. But they weren't my favorite. But yeah, their legs. I would like dislocate all their legs and stuff. I don't know why. Oh, Play-Doh. I forgot about that one. That one's a good one. I loved Play-Doh actually as a kid. Anything like that's like squishy Play-Doh. I don't know. I really, really enjoyed those. My Little Pet Shop toys. Flying dolls? What flying dolls? Flying dolls, that's cool. I mean, I remember the ones that you like, they like twirl like a fairy that I don't know if that's what you mean, but I used to like those. They used to come in like back in the day when I would be excited to get the McDonald's toy. Sometimes they'd have those little flying things. Just bringing back some memories. Welcome, welcome everyone. If you just came in, if you can make sure to answer the check-in questions so I could get you down for attendance. And let me know if I'm wrong here. So let's see. Um, that's okay if you don't remember. A lot of people put don't remember. I don't know why I have quite a vivid memory of toys, but all right, no problem. Okay, so let's see. This is who I'm missing. If you don't remember, didn't have a favorite toy, that's okay. You could just be like, don't remember, didn't have one. Totally fine. This is who I'm missing, and please correct me if I'm wrong. I'm missing Ariana, Tyree, Dennis, Jorge, Miles, Niara. Am I missing Niara or did I mess up? Yeah, I am missing Niara. I'm missing Kayla. Yeah. Alicia, Marco. And that's it. That's who I'm missing. So let me repeat it once more. Ariana, Tyree, Dennis, Jorge, Miles, Niara, Kayla, Alicia, and Marco. So that's who I'm missing here today. If I made a mistake, let me know. If not, Let's let our friends know to come on into class and to get some credit, get some support. Yeah. So it's been a bit, right? It's been about a week, a little more than a week. Again, I hope you all enjoyed your break. This is what we're doing here today for our stuff. So I just took attendance. We're going to refresh. So because it's been a week, let's refresh ourselves. Like, where are we when it comes to the mini final? Where do we leave off? What confusions and questions do we hold on to? Then we'll jump into any questions you might have about the mini final. And there is an activity where we look at two samples of student work. We're going to look at what's similar and different. Usually this helps us, as in it kind of helps us figure out um, how to get started on our own. When you look at other student work, we'll have a checkout. And so this is what it says down here. So the full mini final submission is due Tuesday midnight. But of course, don't let that freak you out. So I'd like at least a draft for those who haven't yet turned in a draft to be in by at least Tuesday midnight. For those who are like making edits, try to get them in by Tuesday midnight. But as usual, I'll always accept all mini finals whenever. So don't let that stress you out. But the only reason why I'm asking for a Tuesday midnight is so I could use Wednesday, which is the deeper learning day, to grade them. So that I give you time to actually grade it before you all head into the next module. I'll grade it. You'll know whether you're at developing or proficient or emerging, and then you could continue to work on it. Does anyone have any questions about this right now? Okay, so the question is, so this is for part one, part two together. Yes, that's right. So full submission, part one and part two together. Get it in by Tuesday midnight, or at least a draft, so I can give feedback to everybody. Yes, part one and part two together. Great question. Let me know if there's any other questions about mini final. Okay, but if any questions come up, feel free to like just put it into the chat, and I'll be happy to come back to it and answer it. Let me go ahead and address the supports I have. That's the next thing. So let's say you're having a little bit of anxiety, um, because like, the mini final, right? So I just want to make sure that y'all are aware of the support that I have. So I just had a small group just this morning. It was right after advisory. I'm very happy at the all the students that came. It was a bunch, and we got like everyone got started. Everyone that came in got started or knew how to kind of get started on the mini final, especially if that was an anxiety pressure. But I'm welcoming and inviting you all to any of my small groups or office hours. Sorry, I was going to make an addition, but never mind. Monday through Wednesday at 10, right after advisory. I'm including Wednesday because Wednesday is a deeper learning day. Wednesdays is going to go from 10 to 11:30. So that is, if you're interested, come on by too. But tomorrow as well, I'm holding another one at 10, right after advisory. So if you need some support, jump into that. Not only that, but Monday and Tuesday, so today and tomorrow at 2 p.m., I have office hours. So jump on in as well if you need some support on the mini final. Or let's say these times don't work for you, reach out in for an appointment with me, and I'm happy to work on you one-on-one on the mini final if those times up here don't work for you. And again, you can resubmit the mini final as many times, even if the module right now is going to be done. So let's say you need like time next week or something. That is okay. I'll be always accepting the mini finals from you all. And again, if stuck, please reach out for support. So let's see if there's any questions on this or anything like that. Let me know. Whoops. Let me pause here to pause for any questions, concerns. Okay, friends, let's go on to today's stuff. So again, here is my support. Please jump in. I'm happy to support you all. It invigorates me to help you all out. Okay, let's jump in. So again, these slides are on Google Classroom, so please open up your own copy. I'm right now on slide number 5. Let's do a quick recap of where we left off right before we hit that glorious spring break that we just had. Right? It was great. So when we left off, we were talking about how to create an equation to model a function, specifically a sine or a cosine function, a function that looks like a wave. So there was different things we had to find. Here were different formulas to find amplitude, a different formula for period. There's something called a phase shift, which is side to side shift of the parent function. Vertical shift is an up and down shift of your function. And then there was a mention of frequency, which actually doesn't come up until you actually hit your mini final. So here you could see the different ways we kind of found each and every component, which was A, B, C, and D. You're going to be doing the same process in your mini final, specifically in question number 3 on the mini final, when you're asked to recreate your sound wave. So that was what we did right before break. We were getting some practice on this. Another thing, of course, right before break is the important definitions you should know. These are on the slides. They're also on your big ideas packet. But these are definitions that you should definitely be aware of and know, because you want to apply them when you're reconstructing your own equation. Things like a period, how to measure that. How do you measure amplitude? What is that? What is specifically a phase shift? What is that vertical shift? And then down there, midline. What is the midline? How do you find that? There's all your definitions. Go ahead and review those. Let's take a few seconds on this one. Okay, so that was where we left off at before we hit our break. Now we're on slide 5. I'm going to jump us into slide 6. So everyone, in order to kind of ease us back into, this mini final stuff and into the work that we're doing, I have 2 different things you can do for the next 5 minutes. We're going to be taking the next 5 minutes to, number 1, refresh what work you've done so far on the mini final, plus develop any questions you might have. So number 1 is, if you had already started on your mini final, you're going to open that up right now. You're going to just review all the stuff you've done. Number 2 is the option. Let's say that you had no time to do your mini final. Let's say you didn't get started. Don't let that stress you out right now. What I'd like you to do, if your option number 2 is just open up the mini final, it's on Google Classroom. You're just going to start to read through it and prepare to think about any questions you might have. Right after this 5 minutes, we're going to be jumping. Right after these 5 minutes, we're going to be going onto a Padlet, and you're going to either be typing out what was done so far in your mini final or what questions do you have. So there'll be 2 options on what to write on the Padlet. So does anyone have any questions about what we're going to be doing here in the next 5 minutes? Let me just make sure I put that there. So our directions are right here on the slide. So let's take these 5 minutes. Again, this is for you to not feel too anxious about it. Just go ahead and open it up, read through what you've done. If you haven't started, open up the mini final and just read through it and just start preparing some questions. After, we'll have a Padlet for your questions. All right, everyone, I'll see you back in 5 minutes. Instructions are on this slide.
But what about the cable? A ver. The computer is charging.
All right, everybody, welcome back. So I'm gonna go ahead and, yeah, this timer's still going. I'm gonna transition us into slide number 7 on our slides, and we're gonna go ahead and go on the Padlet. Let me get the link for you if you're not here with me on the slides. And we're gonna go to, let's check out which column. And we're just going to go ahead and just start putting down any questions we have or where you're at specifically in your process of the mini final. You could put your initials or you could put your name if you're comfortable. Same format. Let me just make sure this is, yeah, this is the right one. Okay, great. So it looks like we're on column number 11. So here's the question once more. What was done so far for you in your mini final? Or I put a little slash, what questions do you have right now about the mini final? Let's go ahead and add your post. And let's take about a minute or two on column number 11. All right, everybody, welcome back. Thank you so much for just putting down like where you're at. Just sometimes this process of kind of just looking over where you're left at, where you started, all of that kind of helps you get back into the work, especially after taking a break for so long. So we're all at different locations. I do want to say, those of you who said you received feedback. So what had happened is that for those who submitted a draft over the break, I gave feedback. I actually did not enter this as a grade. So if you're concerned because you haven't entered in a draft about your grade, please don't be concerned. More so, I had that deadline for feedback from me, but I could totally still give feedback. Just go ahead and let me know or share me, all of that. Um, there's good questions coming up, like how do you know that the equation you made is accurate? So tomorrow, period one is meeting up. And tomorrow I'm going to focus on the equation portion, which is question number 3. Today, more so, we're focusing on question number 2 to kind of talk a little bit about that. And yeah, so there's some honest feedback here. Thank you so much, y'all, for your contribution. Yes, procrastination, it is real. I do want to also remind you all that you do have some advice and tips that were helpful when someone's struggling with a concept or mindset. So just so you know, if you go back to column 1, you all had some amazing feedback, maybe something that you've written yourself to give yourself some motivation as well during this time if you're struggling at all to kind of get started, or if you're struggling a little bit with the motivation. This is also a useful resource that you all can check out right here. So this is column number 1. Some really, really great advice. So feel free to take time to scroll through that. And I'm going to go ahead and take us back into our slide right now. All right, so I am on slide number 8 in our slides. And in the break, I did show you some samples of different sounds that students were making. Some students were doing whistles. I want to also tell you all that I would have done a whistle too, but shamefully, I don't know how to whistle yet. By the way, yeah, I know that probably is surprising. Um, so yeah, that's why I haven't done a whistle, but I've heard whistles do make good waves. So if you're struggling on creating a sound, and if you can whistle, try to use a whistle. Um, or if maybe I should have found a whistle. Okay, great. I'm not alone. Thank you. I'm like, yeah, I can't whistle. And even though people try to show me, I'm like, I don't understand. They're like, put your tongue here and do the. I'm like, I don't know. Okay, but anyways, there was different sounds. Some people recorded portions of music. There was a student that recorded playing guitar noise. That was awesome. There was somebody that actually did similar to what I did. They tried to sing like a vowel, which kind of creates it creates like a sign looking kind of wave if you sing well. Again, I don't sing well, but if I stop it really quick, it gets a good portion that perhaps I sing well for a few milliseconds, which is a very, very small second portion. So anyways, this is a sample of a nice sound wave that you might be getting. So you definitely want to choose something that looks like this. So don't settle for something that looks really messy, because that's going to be hard for you to make an equation to represent that sound wave. So that's just some feedback on that. Let me know if anyone has any questions about your sound or any samples. Okay, cool. And then feel free to check, you do have a copy of these slides, so you could take a look at the samples and listen if you need some inspiration, if you haven't yet done part 1 of the mini final. I'm going to go ahead and take us into the next slide, which is slide number 9. We're going to be zooming in today on question number 2 to get some support on this one here. And if you were in my office, I'm sorry, if you were in my small group today, we kind of talked about this. So this might be a little bit review for small group, but that's okay. It's fine to get a lot of practice. So let's read what number 2 is asking us. I gave some feedback to those who turned this in, so definitely want to talk about this. So number 2 says, display the waveform of the sound. That's just another way to say display your wave. Just take a screenshot of it. And basically what this is, as you remember, like when you're talking and the sound that you hear, it's basically air pressure. You have high pressure, low pressure. That's creating the sound over time. You're going to have this live sound analyzer. And basically, it's linked there for you. You hit the play button, and that's what you're going to do to kind of freeze the image and take a screenshot. You're going to see a wavelength, and you want to make sure it's periodic. So keep trying and testing it. And if not, you want to just replay your sound a few times. What you're being asked to do is estimating from the graph. You're going to estimate what is the period, but then not just that. It says what's the period of the sound, but it says after you convert from milliseconds to seconds. So there's some conversion happening here. Then the follow-up question is, what is the frequency? So finally, that word frequency is coming up. I did link up me trying my best to demonstrate how to use the tool. This is coming from someone that can't whistle and can't sing. So for me, it was super hard. And I can't play an instrument. So it was really hard for me to make a sound. But it's possible if you just give it some time. Give yourself some practice to kind of create a nice sound wave that's going to look like a sine or cosine wave. So this was question 2. And how we're going to start to talk about question 2 is by looking at student samples. Similarities and differences is what we're going to go ahead and transition into next. So we're going to be taking a look at 2 student sample works, and we're going to just notice what's similar and what's different between them. We're going to, again, be back into the Padlet. So same Padlet. I'm going to go ahead and re-put it into the chat, though, in case you close that up. And once you're in the Padlet and you open that up, we're going to go to column number 12. So on column number 12, you see something that looks like this. You actually have to click it to open it. And what I'm going to do is I'm going to click this box up here to kind of open it as a full document like this. And there we go. What you see at the very top of this document is the question itself that we just read through. And what you have are the 2 student samples. So here's student sample number 1. And right below it is student sample number 2. You're going to first analyze. So take a minute to analyze these student samples. Once you're done analyzing, you're going to go ahead and go back to our Padlet, column number 12, and you're going to just jot down a similarity or a difference. And then for this one, by the way, both of these samples are good. Both of these samples are good. So you want to actually give a actual, like, what is similar, like an actual thing that a student did, both, or what's different, like an actual thing. Okay, thank you, JK, that's right. But yeah, thank you so much. So some of you are already ready there with your comments. Let me go ahead and give some time for the rest of us to go ahead and analyze these 2 separate student samples. And just jot down what's similar, what's different. And hopefully it'll also give you some ideas on how to get started with this question. So let's come back. Actually, let's give about 2 minutes. We'll come back in 2 minutes. All right, everyone, welcome back. Thank you so much for your contributions on taking a look at what was similar or different. If you still need some time to write in your post, please do so. Go ahead. I'm just going to go ahead and just talk about this. So a lot of you were mentioning as I was scrolling through here, just the different like wave, like the way the waves look different. For example, this one's waves were more condensed. This one was kind of more like zoomed in or something like that. Maybe we could say that this one's higher frequency than this one if the waves are more closer together. Now, I couldn't really zoom in. I think that says 5.06 milliseconds, and this is 1.5. So that one for surely has a larger wavelength than does this one. So this one is indeed higher frequency. So what that would mean is that this sound is more high pitched as opposed to this one, which has a lower pitch. So that's kind of like what you all were pointing out there as far as why the sound waves looked a little different. I do want to point out a last comment that was made all the way down here. Oh, one of the last ones. It says on the one difference is that student one went through converting milliseconds into seconds, and they both were able to identify the period of their graphs. And I also want to point out another one up here that says one graph is showing the period between two minimums and the other one is showing a period between two maximums. There might have been a term for that. Yeah. I don't know if there's specifically a term. I said it that way too. Finding the period between two maximums, or you could find it between two minimums. So these are both correct ways to do it. And that is how you actually find the period or the length of one cycle in your sound. And that's definitely what you want to do if you haven't yet done this. The mention was that this student right here showed their steps on how to convert from milliseconds to seconds. Let's see, this student did indeed mention it, but we don't see that conversion in the end. One thing now, I don't know if anyone kind of pointed this out, but one thing that I'm noticing right now as I'm taking a look at these two samples is that this student like did a great, excellent job by showing how they converted milliseconds to seconds, which was one of our asks, right? It says, what is the period after you convert from milliseconds to seconds? So that's awesome. They showed that conversion. So that's very clear to us. But one thing that student sample number one didn't do, that student sample number two did do, is the frequency. So one tip for me right here is taking a look at these student samples is to make sure that you're answering the questions fully. So if there's a two-part question, you want to make sure you answer that second question. So I don't see that frequency is answered here. So what is the frequency of this sound? This student right here is indeed trying to answer what the frequency of the sound is. And they're using a formula there to figure that out. So those are like the two different things I'm seeing. Let me know if anyone wants to point out anything else. But what I'm going to do right now is I'm going to go ahead and I'm going to zoom in on sample number two, and I'm going to give some feedback that we could all use. Okay, let's do this. So first off, thank you all so much for identifying those similarities and differences. So I'm going to go ahead and take us back to our slides. I'm on slide number 11. I'm going to zoom in on student sample two. Once you all kind of read through these two separate samples and kind of know what each student did, I'm going to give some feedback. So this is just general feedback that we could all benefit from. So I'm just kind of pretending that I'm looking at this my first time, and I'll start to give some feedback. Again, I have the question right here, just in case if you need a refresh, or just always go back to the question, make sure you're answering the question fully. So some things that you need, by the way, in order to kind of make sure that you're making adjustments with feedback, I recommend having your big ideas packet open. all the way to the top so it's easy to get our links. So have your big ideas packet open because I want to remind you that you want to strengthen the justification in your mini final by supporting it with a big idea. So make sure you have this open when you're making your edits. Let me go back to my slide. All right, let me go ahead and take a look and read this. So we have, I know the sound is periodic since there are points to which the pitch makes the point is approximately to having the same length for the sound. I'm getting the gist of that, but to strengthen that first sentence up, my feedback will go to open up your big ideas packet and go to where we talk about periodic functions to kind of strengthen up the wording that we're using when we're talking about whether or not something is periodic and what does it mean for something to be periodic. So here you can read up a little bit about that, and there's various different examples to kind of strengthen what it means for a function to be periodic as you're describing that. I really think that was awesome that this particular student took the time to kind of like talk about what does periodic mean to them. So that would be my first little feedback there. Then we have that the period after converting milliseconds to seconds would be seeing the frequency. So right here, the period, let me try to underline this. After, well, it's horrible, sorry. Converting milliseconds to seconds would be seeing the frequency. So one of the questions is asking you to first off convert the period to seconds, from milliseconds to seconds. Second question is asking you to tell us what the frequency is. So the first thing is we want to make sure that we're converting this student's period into seconds. So let's do that. What we could do is we could totally look at what the other student did. So they also converted to milliseconds and they did show their steps. But let's say that we need some support. I'm always for Google, by the way. So it looks like this student got that a period of one wave is 1.50 milliseconds. Let's work on converting this into seconds. This is what we do, y'all. So we're gonna have to multiply by something. Let me know if anyone knows how many milliseconds are in a second, but I'm gonna go ahead and Google it if we don't know. So just how many milliseconds are in a second? Oh, there's something in the chat. Yes, okay. I got a direct message. Someone said 1000 milliseconds are in 1 second. That's correct. And if you didn't know that, see how Google is so powerful? 1 second is equal to 1000 milliseconds. I'm going to use that to go ahead and convert my milliseconds to seconds. So let's do that. 1.50 milliseconds times the fact that 1 second, so 1s, is equivalent to 1000 milliseconds. MS. So once we set this up, y'all, let me ask you in the chat, what cancels out here when I'm writing this out? So this is 1s, 1 second. That's not 15. That's an S right there. But what cancels out here? Yes. So we have a general consensus here that milliseconds will be canceling out. That is correct. Let me just cancel that out right here. And that shows us why this multiplication is going to lead us into seconds, which is what we want for this. So what we have to do is 1.5 times 1. Then we're going to divide by 1000. Basically, 1.5 times 1 is just 1.5 or 1.50. And we have it now in seconds divided by 1000. And we're going to get finally what the seconds is. And let's see, I'm gonna use my phone. Earlier my phone wasn't working, but let's see. I mean, the calculator, I don't know what was wrong with it. So 1.50 divided by 1000 is going to give me, oh, did somebody already do it? Oh, thank you so much, Nyara. We got 0.0015 seconds. 0.0015 seconds. So the period length, so that's us answering the first part of the question. The period length after we convert to seconds is 0.0015 of a second. What I did right here was what student sample number 1 did. Student sample number 1 did show how to convert. They did show it in a different way. So they did it like 0.00, like they did it in a different way, but it's similarly is the same thing to get to the answer. So this is me borrowing kind of like the strategy that student 1 did to kind of go into this. And then it's cool because student sample number 2 can help student sample number 1 because student sample number 1 forgot to calculate the frequency, which is what student sample number 2 does. That's why I really love these two samples. So I think student sample number 1 did not yet convert to milliseconds, but they did mention the fact that we needed to do frequency, and they have it right here. So let me just clear up the underline. And I also want to say this. Go to your big ideas packet. Let's say, I don't know what frequency is. Let's go here and let's find where we see frequency. I see it in big idea number 10. So here is a little general thing about frequency. This is low frequency, high frequency. I even included a student sample with some work on here. And the formula to find frequency appears down here. The formula is F equals 1 over P. Basically, it's 1 divided by period length. And you can see the student sample right here and what they did. So once we have the period length, that's this, 0.0015 seconds, let's go ahead and finish this up by finding the frequency. So frequency formula, it's in our big ideas packet. It's also in our slides. Again, we didn't get to use it, right? But it's generally a plugin. Frequency is 1 over the period. After you convert to seconds, you're going to go ahead and substitute. This right here is going to go down into the denominator position. 0.005 seconds. And then we're going to finally get some frequency that's going to be measurable in hertz. That's going to be the units hertz. So feel free to like use a phone or something to verify what you're getting. So it's 1 divided by 0.0015 of a second. That's going to give us frequency in hertz. Oh, what do we get? Let's see. We got 200. 200. I'll go with that. Let's do 200. So it's 200. 200 hertz is our frequency. And that would be how we would kind of make some adjustments to this student sample, which was already amazing to begin with. Just a little bit of adjustments. Mostly it was just a fixing up of converting the milliseconds to seconds. And again, this right here, feedback for sample number 1. If you forgot to do frequency, don't forget it. It's right here, a little sample. Now, what's the exciting thing about this is once you have your frequency in hertz, on question number 4, once you get to it, let me open up the mini final first off. On question number 4, you're going to be asked to put your frequency into a sound synthesizer. And you're going to be able to check if it sounds similar to the sound that you made, either if it was a whistle or if you were singing. So for example, for this particular student, we calculated 200 hertz. On question number 4, you're going to be asked to go ahead and try to test out if you get a sound that sounds like the sound you made by putting in the hertz. So right here, you see this. It's set to 440 hertz. I'm going to fix it to say 200 because that's what we got, 200 hertz. The volume is off. I'm gonna turn it on. So this is what it sounds like. It sounds kind of low. It's not really a high frequency kind of sound. So it sounds like oh. So I don't know if the student did like oh or something, or they probably did it. I don't know. So if it doesn't sound like your sound, what you're gonna be asked to do in question number 4 is you play around with these little harmonics. These harmonics can change your sound. Like so, you can just play around. And then try to like best match up what your sound really did sound like. How you turn this off is you actually have to just go back to 0. So that's what we're going to be like ultimately doing. And that's why we had to kind of convert your frequency to hertz, which is why we needed to convert milliseconds to seconds, because hertz is measured in seconds. So that was a little bit of the why in that portion. So that's going to be kind of fun. It would be funny to prank someone with this. Yeah, it totally would. Um, yeah, and I also wonder how Siri is able to, kind of interpret what we're asking it to do. And it makes me wonder if it uses sound synthesizers or something to kind of interpret what people are saying. So hopefully that was helpful. So that was just general feedback for everyone. This was coming up for a lot of us. So feel free to ask any questions if you have any about feedback I just gave. Like playing it and acting like you don't hear anything. Yeah, oh my gosh, yeah. Sometimes you end up hearing those. It's really annoying. All right, I'm gonna go ahead and clear the screen unless there's any burning questions before we jump into the checkout. Okay, y'all, I hope this was helpful at least for question number 2. Tomorrow we're gonna come back. We'll talk a little bit about question number 3, which is the equation part. Here's my general feedback though, y'all. Make sure your screenshot includes your Y and X axis so that your work is replicable. Use that measurement tool to calculate the period. Don't forget to convert milliseconds to seconds like I just demonstrated. And in part 2, we'll talk a little bit about this tomorrow, but how are you creating your equations? Make sure that you're letting us know what were your steps to creating those. All right, let's jump into our checkout, y'all. Either what questions do you currently still have? Let's say I haven't addressed your question yet. What do you still have? Or is there anything you'd like to share as a tip for the mini final? Perhaps for students who haven't yet started, like what are some tips you might have for them? Or again, any questions you have? This is our checkout, y'all. Okay, no problems and no questions or tips. Awesome, awesome. And I gave my tips in that last slide for tips. Um, Any other questions and or tips that anyone would like to offer? Maybe a sound that was very easy to make a nice sine or cosine wave. And then we have, I question if I can actually do this. I was so in doubt today. That's okay. That is so real because we just came back from break. And let me tell you, I'm feeling that too. So it's real. By the way, my office hours is at 2 today. If anyone needs to jump in, I'm happy to work with y'all. Ooh, and how come the alarm sound didn't work for me, Francisco? I tried doing that today in small group and it was horrible. But I'm glad that it worked for you. It was like doing something crazy when I tried to look up an alarm sound. We got no questions, understood everything. We got no questions right now. And oh, there's a different alarm sound. Yeah, it was one that sounded like really like I got it from YouTube, but it really wasn't working. I feel like in general, people who are doing whistles are getting some good waves. Oh, the default sound of my phone. Okay, so that might be a tip for some of y'all struggling with the noise and how to get a nice wave. Try to look at what are the default sounds on the phone to see if you could get a good wave. Or try singing if you could sing well. Like I said, that was a struggle for me. All right, everyone. Any burning questions or tips, feel free to let us know. If not, y'all have a great day. I'll be here for any support, everyone. Yeah, bye. Bye, y'all. Thank you so much. Bye,
Bye, Miss
everyone.
Sedano.
Bye, Tara. Bye, y'all. Bye, Gian.